In today's lesson, we are going to be looking at transformations of rational functions. So we've already looked at transformations in general, transformations of quadratics and radical functions. Now we're looking at the last type of function or specific type in this unit, rational functions. So rational functions we've already dealt with. We've dealt with them when we were trying to simplify rational expressions, and we've kind of looked at them a little bit when we looked at domain and range and restrictions. But just a quick reminder, base function of a rational function, f at x equals 1 over x. So that's our base function. So when we go in to enter our key point, let's do -2, -1, 0, or sorry, -1, -1 half, 0, 1 half, 1, and 2. So those would be our key points. For our y value, then, when we plug that back in, right, this would be the f at x equals 1 over x. So when we do 1 over x, we get 1 over 2, sorry, -1 over 2, -1, -2, undefined because we can't divide by 0. We get then +2, 1, and a half. So I can go through and plot these points. So -2 and a half, negative a half, -1 and 1, half and -2, nothing at 0, 1 half and 2, 1 and 1, 2 and a half. We should see something roughly like this. So that is what our base function looks like. And again, remember we talked about we do have asymptotes. We have a horizontal and a vertical asymptote, both in this case at x equals 0 and y equals 0. So we don't have any values along those points. Just a quick reminder, right? For the two asymptotes, we have our vertical one, and that would be the one that we see here, the x equals 0. That's that asymptote, that's that line, right? Because we can't divide by 0. So we can't have an x value of 0. We've talked about restrictions before. That is a restriction of this rational function, right? That is why there is an asymptote for this vertical line. We also have a horizontal asymptote, right? So for the range, there can never be a situation where we divide to get a result of 0. So therefore, the line y equals 0 is a horizontal asymptote. Right? So our horizontal line here is also an asymptote. It's going to look like our function touches it, but in actuality, if we were to zoom in on those sections at the ends of the tails on either side, positive and negative, it would never be touching. There would always be a space there. Right? And the key thing, right, again, we have a denominator with our variable in there. And when we have a denominator that has a higher degree, or basically a higher exponent on a variable than the numerator, then there will always be a horizontal asymptote. Oops. So we have kind of two asymptotes to consider when we're looking at rational functions. So we're just going to jump right into it because, again, we've talked about the transformations before, so I'm not going to go into too much detail about the specific transformations. If we don't remember them, please make sure you go back and look at the first lesson that talks about the transformations in general, the variables that tell us what our transformations are. So we want to describe the transformations that apply to the base function and then write the corresponding transformed function. So I'm just going to go through and highlight my values. Right? Any numbers we see or negative and positive or negative signs generally mean that there's a transformation there. So here I have an a value that's equal to 4. So this tells me I have a vertical stretch. Can't spell that. Stretch by a factor of 4. And again, if we want to kind of know what's happening to our values, this would mean that our our y values are being multiplied by 4, or 4y. We have a d value of +3, again, opposite of what we see. So d value of +3, this means we shift right 3 units. And what's happening to our values? Well, in this case, our x values we're adding 3 to them. And then lastly, we have our C value, which is 0.5. So that means we shift up 0.5 units. And what's happening to our values? Well, our Y values are being added or increased by 0.5. Now, we want to write out the transformed function. In red, we have all the transformations that are happening and what specific values or variables they're applying to, right? Our Y or our X. So I'm going to write out my transformed function. And similar to our other ones, any change that is happening to the X variable has to happen to the X variable in our parent function, right? So if I look at our parent function, I'm just going to write it out here in black. Our parent function is 1 over X. So that means all of the change, our X value is on the bottom. It's the denominator. So all of our changes that happen to the X value should be applied on the denominator. Right? It's almost like we're replacing, we're putting this function in and then applying our transformations. If they don't affect the X, they're outside of that 1 over X. If they do apply, they're attached to it. So in this case, we're going to have 4 first. Oops, let me get my colors right. We're going to have 4 first. That's affecting the Y, so that's going out in front. We are going to have then our 1 over X. But we do have a transformation applying to the X, which is that we have to add 3. So it'll be X plus 3. We can then close our bracket. There's no other changes affecting the X value. We do have another change or transformation affecting the Y. We have that plus 0.5. And now we're done. So we can see kind of a similarity between our transformed function and our general function, right? We see the 4 and the plus 5 on its own. We see the minus, oops, I made a mistake. It should be minus 3. Right? So we see the minus 3 in brackets with the X, similar to our general transformation. There is one other thing we can do with this rational function, and it applies to the A value, because what I can do is I can actually multiply that 4 through, or 4 over 1 as a fraction. So this would become 4 over X minus 3 plus 0.5. So this is my final transformed function, right? It's the simplified transformed function. For B, we're going to go through and do the same thing. Right? Different transformations. So I'm going to highlight all my values. I have a K value of -2, which becomes 1 over -2, right? Because our factor that we apply is the factor of 1 over K. So this tells us we have a horizontal compression by a factor of 1 over 2. We also have a horizontal compression. Not compression, I already did that. A horizontal reflection because of the negative value. So what's happening to our X value then? Well, this is telling us that our X value, we are going to multiply it by -1 over 2x, or -x divided by 2. We have a D value, which is going to be a -0.5. So this means we shift left 0.5 units. So again, what's happening to our values? Well, our X values, we're subtracting 0.5. And then lastly, we have a C value of -1. So this means we shift down 1 unit, or our Y values are subtracting 1. We're subtracting 1 from our Y values. I want to put this into a transformed function. So g at x is equal to, there's no A value, so I can just go right into my X portion. So I'm going to have a -2x plus 0.5. So again, anything that's happening inside that f or in our general function that's applying to the x is going to go directly with the x in the denominator. Similar to how before it went under the radical or the square root sign, or it went underneath or enclosed by the square in the quadratic. We do have then the -1 for the c value, so that's going to go at the very end. I can't simplify this any further. There's nothing I can really kind of do. I can't multiply that a value through. So now I have my transformed function. The next portion is going to be pretty much the same thing, except now we're going to actually graph our transformed function. So we want to make a table of values for the parent function, describe the transformations, make a table of values of the image points, or use that mapping notation, graph the transformed function, and write its equation. So a little bit to kind of work at. So first I'm going to do the parent function, because again, we've talked about that before. We have that right on our first slide. So we did -2, -1, -1/2, 0, 1/2, 1, and 2. -1/2, -1, -2, undefined, 2, 1, and 1/2. So that's our parent function. We're not going to graph the parent functions for these just because it is a little bit harder. It is a little bit harder to kind of show all of it because there's two portions of it. So we're basically drawing like kind of like 4 different things. So it's a little bit harder. Let's go through and list our transformations. So looking at our parent function, we have an a value equal to 2. So we have a vertical stretch by a factor of 2. So this means that our y values are being multiplied by 2. We have a d value of +1, so this is a shift right 1 unit, or our x values are adding 1, and our c value is equal to 2, so this is a shift up of 2 units, or our y values are adding 2, or we're adding 2 to our y values. If I wanted to use my mapping notation to kind of quickly jump to the key points, it would be x. Oops, let me use a different color. We had x over k plus d, and we would have ay plus c. So I already have all the kind of mapping notation kind of laid out in our transformations, but it does help if I can kind of compare it to make sure I have everything right. So my x values, the k value is 1, so x divided by 1 is just x, and I'm adding 1 because of the d value. So x plus 1, and then for a, or for the y's, it's 2 for the a value, so 2y plus 2 for the c, so that matches kind of what I've had. Now we can go through and apply all those transformations. So my x values, I'm just adding 1. So we're at -1, 0, 1.5, 1, sorry, not 1.5, 0.5, 1, 1.5, 2, and 3. For my x, or for my y values, again multiplying them by 2 and then adding 2. So -1/2 times 2 plus 2, we're at 1, 0, -2. Here, this is still going to be undefined, right? So because there is, I can't multiply undefined by anything or add undefined by 2 or add 2 to undefined. It's just going to stay undefined. And then we have 5, 4, and 3. So now I can go through and plot my points. Right? So -1 and 1, 0 and 0, and 1/2 and -2. Draw something like that. And I'm going to have at 1.5 and 5, 2 and 4, and 3 and 3. We could draw those points now. Now, one thing to note, so we have our two sides, we have those kind of two parts. We do have asymptotes, right? So if we look, we can see our horizontal and vertical asymptotes. Let me just see what colors did I use. Pink for the horizontal. I'm not sure if that's the same for the first one, but our horizontal asymptote, we have one coming across here. And we can see the vertical one along here, which we also see in this undefined section is where our vertical asymptote would be. Now we also see these in our equation, in our transformed function, right? That -1 or that +1, we see that in that d value. So this would be our vertical asymptote. And we see the same thing for our horizontal one with that d value. So in the transformed function, it does give us what our asymptotes are as well, based on the shifting left and right and the up and down. And that's because in that base function, our asymptotes are at 0. So however we shift it left or right, that's going to be our new asymptotes. I still need my transformed function. So this would be g at x is equal to 2. And then in brackets, now I'm going to do the 1 over x minus 1 plus 2. So we see the similarities between the two, this and the general function. We can simplify this and make it g at x is equal to 2 over x minus 1 plus 2. So I can kind of multiply that a value through the first part. And so here we have our transformed function. There's one more example, and we're going to do the exact same thing, right? Our parent function, let's get that out of the way first. So -2, -1, -1/2, 0, 1/2. Oh, yeah, 0, 1/2, 1, and 2. We have -1/2, -1, -2, undefined, 2, 1, 1/2. And now I can go through and list my transformations. I see a negative out front, I see a 2, the plus 0.5, and a -1. So quite a few transformations here. A value of -1 tells me a vertical reflection. We have a k value of 2, which becomes 1 over 2. So this is a horizontal compression by a factor of 1 over 2. We have a d value of -0.5. So this is a shift left of 0.5. And we have a z value of -1. So this is a shift down of 1 unit. Now I didn't put in what the values or how that's going to affect the x and y values, because I'm going to use that in my mapping notation. So I'm just going to do this example just if we just did the mapping notation. So the mapping notation was x divided by k plus d, and for our y value it was ay plus c. So I can plug in all my variables into this. So x divided by k, or x divided by 2, plus d, which is -0.5. And then I have -1y minus 1. So whether you do the mapping notation or writing down the change, or how each transformation affects the variables, either way you should still get this or these values or these changes to the x and y value. So now we can apply those changes. So -2 divided by 2 is 1 minus, or -1 minus 0.5 is -1.5. We just kind of continue that down with each previous y value. We end up with -1, -0.75, -0.5, -0.25, 0, and 0.5. And then on the y side, we have -0.5, 0, 1, undefined, -3, -2, -1.5. I can take all of those points and now plot them. So -1.5 and -0.5, -1 and 0, and -0.75 and 1. And the other side, -2.5 and -3. 0 and -2, and 0.5 and -1.5. So those are the points there. It's a little bit harder to graph it if I don't really know the asymptote. So I'm going to go back and take a look. I can see my horizontal asymptote. Right? You see that as the -0.5. So I know that around here, or sorry, not my, I'm getting them mixed up. That's my vertical. And I can see that from the other one. So my vertical, which should be in green, let me go just switch this around. So my vertical asymptote, again, it's kind of opposite. So that's a good way to kind of remember it. Opposite. So we have at 1.5. I'm just going to use a ruler. I'm going to cheat a little bit just to make it nice and straight. So I have my vertical asymptote here, and then my horizontal asymptote is the C value, which would be along here. Oops, no, I don't need that for this one. So now with that, it's a lot easier to kind of sketch our function because we know how or what it's going to approach. And again, that's kind of why we just call it sketching. It's not going to be 100% accurate. We just want to kind of see what it is, and just so we can see how it's been transformed. We still needed our transformed function, so the g at x is equal to, we're going to go back, take a look. So we have a -1 outside, so -1, and then we got a lot affecting the x, so it's going to be 1 over 2 times x plus 0.5, and then -1 on the outside. We could kind of combine that a value, so it's going to be -1 over 2x plus 0.5 minus 1. And that is our transformed function. So nothing's really changed in this lesson other than what our parent function is, or our base function. So our base function in this lesson is the rational function, the 1 over x. So that's why our transformed functions look a little bit different, but the same transformations are being applied, that the a, k, d, and c. So again, we need to really make sure we know what they are, so that we can apply these transformations to different functions.